This program is presented by the Associated General Contractors of America.
The 1990s. It's our decade for improving construction safety. Improving worker safety, reducing liability, and complying with OSHA standards are goals shared by quality contractors. They know that safety on the job means good business. This video, covering excavation and trenching safety, is one in a series designed to help contractors and their employees reduce the chance of accidents and comply with OSHA standards. Excavation and trenching work can pose serious safety problems, especially when cave-ins occur. A concern for preventing these cave-in accidents has prompted OSHA to issue a standard covering excavations and trenching operations. When you realize that cave-in accidents are 15 times more likely to result in death than are common work accidents, it's easy to understand the need for this standard. To help you understand the OSHA requirements and establish a workable plan, this video has been designed to provide a summary of the requirements and examples of methods you may follow to establish an effective excavation and trenching safety program. Let's see how one contractor begins to use the new OSHA information.
Didn't think I'd see you today. Things are pretty much on schedule here. I was just about to head on over to the East End job.
I want to tell you that I've got the plans for a new job. Come on by the office after your last stop and take a look at it.
Great! What kind of job?
Well, it's a tie-in job at the convention center, working with the utility group on the new development. Seems like a good project.
Oh, yeah, Fritz told me about that one. Okay, I'll see you later. Well, I've had a chance to go over these drawings, and it looks like we'll have to get Max in here with the big backhoe. We'll be cutting ditch pretty deep in through here. We might need to timber. Can't tell till you get right on into it, of course, but it might wind up costing us some extra money. We'll give it our best shot and hope we hit good dirt.
Oh, just a minute. I just got back from a seminar on trenching and excavation safety. What about these plans? Is it a full set with a site analysis? What about a soil report? We can't just hope for good dirt and then wind up losing our shirt, or worse yet, losing a life.
I see that seminar had an effect.
I've been in this business too long to be a smart aleck. There's a lot more to consider than just man-hours, equipment, materials. We've got to plan this right to do a good job, make a profit, and safeguard the crew. Besides, we've got to comply to these new government requirements.
Well, that's okay for the really dangerous jobs, the big ones. Not this. Heck, you've been working for, what, 23 years without a problem? And without this.
Hey, these are the 90s, and things are different. We're digging deeper, putting in bigger pipes, and we're almost always working ground that's been worked over regularly.
Yeah, you've got a point. So, where do we start?
We're going to develop a plan to work from. That'll give us a smooth job that's safe and profitable. Remember Mike Benson's cave-in a couple of months ago? Well, if he'd done his homework, checked the soil, talked to the right people, we could have avoided that.
Yeah, but nobody was hurt over there.
Oh, yeah? He got hurt. In the checkbook, he lost 5 days of work, got slapped with a fine, and now he's maybe facing an expensive lawsuit.
Okay, let's start planning this job.
Great. We start by looking at anything that could affect the safety and production of the job. So a complete set of plans are needed. We want to see if the utilities are marked on the site plan. And if they aren't, we've got to call the local underground utility location information agency to find out.
Here, I'll start making a list.
Good idea. Okay, you've got utilities down. Next, put down surface encumbrances.
What?
Surface encumbrances. Okay, that's all the stuff around the site that could get in the way or fall in, like sidewalks, signs, posts, trees, or walls, or whatever. They've got to be identified as possible hazards and moved as supported. Next, put down access and egress. That means any ramps, either for workers or equipment, that go into the trench.
Who decides on the types and construction of access and egress?
Current regulations allow us to make a lot of decisions. But where it doesn't, we have to consult with a registered professional engineer. Did you put down egress?
Yeah, but exit is shorter.
Same difference. All excavations deeper than 4 feet must have some means of exit. Ladder, ramp, stairway. And placed so workers don't have to go more than 25 feet to reach one.
Exit ladders. Got it. Next?
Exposure to vehicular traffic. Just put traffic. You know how often we're working in the middle of the road. We need to provide safety vests for the flaggers and anyone exposed to passing traffic. Next is exposure to falling loads. Workers have to stay away from any loads while digging. Protection for operators must be provided too. Warning system. You know, backup alarms for equipment, barricades for trenches and machinery.
Yeah, we've got all that. You know, most of this is sounding like just good common sense to me. We've also got to think about how deep the trench is going to be and how long it's going to be open.
Yeah, but here's something I bet you wouldn't have thought of. Hazardous atmospheres.
Here we go again.
No, now listen. This is another sign of the times. What if you're trenching in a landfill area where you could have methane? We'd have to test and make sure there's enough oxygen in the trench and ensure a safe, non-explosive atmosphere.
I guess that would be something new for us. Think that would include all the times we're working around gas pipes?
Right. See, this isn't all just ordinary stuff. So make another heading there. Emergency rescue equipment. That means emergency breathing equipment, safety harness, basket stretcher. And these kinds of things need to be nearby when working in hazardous conditions or when hazardous atmospheric conditions may be expected.
Check. Next?
Water. We have to keep trenches dry, pump if necessary, or go to well points.
Boy, that's for sure. There's nothing that'll ruin a job quicker than having water standing in the trench. In fact, when we see that runoff could go into the trench, we've always built some kind of diversion around it.
Right. Now put down stability of adjacent structures.
I suppose that means when you're trenching next to a foundation or something?
Uh-huh. If you're trenching near an existing footing for a wall or building or whatever, you'd be removing the dirt that helps to support it. So you've got to reinforce it with underpinning or shoring of some kind.
You know, that could go for sidewalks and pavements, too.
Here's the next one. Protection from loose rock or soil, which simply means that loose materials must be scraped from the walls of the excavation, or sheeting must be provided to stop or contain falling material. And the soil from trenching has to be at least 2 feet from the edge of the trench.
Now that's something we should pay more attention to. I've often looked at those soil banks and thought about them sliding into the trench. So, got any more?
Fall protection. This means if workers have to cross over a trench, that a walkway with a standard railing is necessary. Here's the last for our list, and maybe the most important. Daily inspections. This is probably the single most important thing for safety on the job. You can have everything else in place, but if conditions change or workers don't follow the rules, the chance of a problem really increases. The trench, the area around it, and any protective systems needs to be inspected by a competent person before work starts and throughout the shift as needed, and after every rainstorm or other hazard-increasing event. And that if a hazard exists, that workers can be immediately removed from the situation until it's corrected.
Sounds to me like this competent person has to be able to make some quick decisions.
He has to be able to take immediate action and not be wasting time looking for someone to approve emergency action.
That's why we should only designate our most experienced and best trained foreman as competent person.
Let me see that list, Joe. Utilities, surface encumbrances, access and egress, traffic, falling loads, warning systems, hazardous atmospheres, rescue equipment, water accumulation, stability of adjacent structures, loose soil, fall protection, daily inspections. Well, this is what we have to follow before we dig and watch when we're down in it.
Seems pretty complete, and you're right. It's got me thinking about a lot more before we just go in and dig.
That seminar had some scary statistics that really made me stop. Did you know that excavation and trenching is one of the most deadly types of construction work? And you don't need to be buried to die either.
So, we've looked at all of this, but when do we actually put a shovel in the ground and get on with it?
After we've done a conditions analysis or analyze the actual site conditions, we've got to know what the soil is, if we've got good dirt or bad dirt. And when we're running a line for over a mile, we know that it's not going to be the same dirt all along the way. We know we're going to need a protective system since the soil here is questionable and all the rest is deeper than 5 feet.
Well, along here where we've got a wide space without much to get in the way, we can slope out the sides of the trench, right?
There's plenty of information available on protective systems, whether to slope, shore, or shield. And then there's all this information on soil classification, details on sloping and benching, timber shoring, aluminum hydraulic shoring, and so on.
What's the soil part? Dirt's dirt.
Not when you need to know how far back you got to slope or bench. See? There are standard classifications for different kinds of dirt, whether it holds together well like clay or whether it falls apart like dry gravel and sand. There are 3 main classifications of soil in addition to rock. There are Type A, Type B, and Type C. Type A is the very stiff and cohesive soils without fractures and cracks. Type C is the bad soil that's not cohesive and is sometimes runny. The stuff that we usually use sheet piling in. B types are the soils in between, the cohesive limestones and clays that we usually work in. Look on these charts. See that the maximum allowable slope for a Type B soil is 45 degrees or 1 to 1. But if you're in a Type C dirt, which is less stable, you've got to slope more, 1.5 to 1. And those are the absolute maximums. There are other site conditions that could mean you need to slope even more, like a nearby highway with a lot of traffic.
So?
It could set up a vibration that would loosen the sides and cause a cave-in. These things are really important. Here, make another list. Call it site conditions. Put soil type right at the top, because that's what it all comes down to. Then put surface water. We should look at the way the ground slopes at the site to see if we need to build some kind of diversions for runoff.
We always check for overhead wires, too. I'll put that down. Say, how do we get more information on soils?
There are some tests we can do ourselves, like take soil samples and give them visual and hand tests. You can take a handful of soil and try to form a ball and roll it out into a thin strip. If the soil has plasticity and is cohesive, which means it's a stable soil, it'll roll out without breaking. If it crumbles apart, it isn't plastic and it's non-cohesive. There's an entire section on soil testing in here so we can tell what we're dealing with. The important thing to remember is that soil has a certain stability. Okay, so we've given ourselves as much good information as we can about the site and can start building our plan. You said that this area here, we can do wide sloping. What about benching?
That could be an alternate. What does the book have to say?
From the looks of it, benching is for cohesive soil conditions only. And you follow the same rules for sloping. For example, the maximum allowable slope for Type B soil is 1 to 1 or 45 degrees.
This diagram shows a shield in the trench. That's probably what we'll be doing where we're getting a little short on right-of-way width. Here, let me look at this. Sure. See, it shows the shield extending above the excavation 18 inches.
And above the shield, you follow the guidelines for sloping depending on soil type.
But as we get into working through this area, we're going to be real tight, so we'll be shoring up the walls. We'll probably be using timbers.
There are tables here that show you how many braces you need, what size, how far apart to space them, the size of the wailers and uprights. Again here, it's all by soil types and by the type of lumber, you know, oak or fir.
I agree we need to be careful about all this, but we're not some huge company. This is getting sort of technical.
Lives are lives, whether you're a big company or a little one. And where the project gets too technical, we've got to rely on professional help. These tables and diagrams we're looking at only apply to us if the trench is less than 20 feet deep. Anything deeper than 20 feet needs to be designed by a registered engineer.
Are there any other tables we can use?
Sure, provided they are properly designed. There are other manufacturers' tabulated data and design approved by a registered professional engineer.
Well, it looks like that's going to be the case through this stretch of the project. We'll need to give our consultant some lead time on this.
You know, depending again on soil conditions, we could use an aluminum hydraulic shoring system. It might make things go faster through this part. The regulations also show data for designing vertical shoring and systems using wales or sheeting. Many manufacturers publish their own acceptable data.
The thing I like best about those is that they're easy to handle. You can put them in, take them out, without going into the trench.
In fact, that's what it called for. Installation starting at the top, removal starting at the bottom. Okay, let's see how our plan is shaping up. We're going to evaluate all of the site conditions all along the route. Anything that could have an impact on this project, from heavy traffic to water runoff to the possibility of running into hazardous waste.
We're going to do a thorough soil analysis all along the way, too, because we know we'll be running into a combination of good dirt and bad dirt.
And we're going to use that soil analysis to determine the safest and the most efficient way of providing protection to the workers.
And we'll design a protective system based on acceptable data, and where we're getting deeper than we should, we'll use our registered engineer to design the system.
That's it, Joe. We're going to plan this project out to build it safe and bid it right.
Sounds like the right way to do it. There's just one more thing, Bill.
What's that, Joe?
The next time you go to a safety seminar, take me along.
Of course, safety is more than just going to seminars. It's using the information to plan and implement improved safe work methods. Since this program was an overview of the subject, many areas were only discussed briefly. Besides knowing the soil type and choosing the proper protective system, we must stress the importance of using the one call for utilities in your area. Be sure to learn your local symbol and phone number and call before you dig. Take the time now to read the OSHA standard and evaluate the type of projects you work on. Then develop a workable plan to follow. Remember, safety means good business.